All right, so let's talk about local maximums and local minimums, okay? So taking a look at this graph right here. So this point right here would be called a local minimum. And this point right here would be a local maximum, right? So this would be a minimum. This guy right here would be a maximum. Now, when you're trying to determine if a point is a local maximum or minimum, right, you have to look at the sign diagram for the first derivative, okay? So let's make the sign diagram for the first derivative, right? So we've got, so this x value is 1, all right? So at 1 here, now you want to think, the first derivative represents the slope of the tangent line, right? So the tangent line at this point right here is 0, right? Because it's a horizontal line. So that means when x is 1, this is where the derivative would equal, all right, 0, because the tangent line, the slope is 0, okay? Now over here, when x is 5, right? When x is 5 right here, the tangent line is also, right, has a 0 slope, right? The slope is 0. So these values here, 1 and 5, these are the x values, right, on the sign diagram of the first derivative that make the first derivative equal to 0. Now, if you think of, all right, the tangent lines, right, so think of all these points here. So over here, when the graph is decreasing, we know that the tangent lines all have negative slope. So that means that over here to the left of 1, right, the sign diagram would be negative. Now between 1 and 5 here, we see that the function is increasing. So it's increasing right here. So we know that the sign diagram between 1 and 5 is going to be positive. And then to the right of 5, we see that the graph is decreasing again, right? So we know that the sign diagram, right, to the right of 5 is going to be negative, okay? So looking at the sign diagram, how do we know if it's a minimum or a maximum? So you want to think, if it's going from negative to positive, so just think going from negative to positive, right? So basically it's going down and then it's going up. So that means that this point right here, you notice that it's at the very bottom. That's how we know it's a minimum. Over here, if it's going from positive to negative, so positive to negative, right? So that means that at this point right here, it's the highest point. It's going from positive and then negative, okay? So basically the idea is, well, on the sign diagram, if the sign changes from negative to positive, you know at this point it's a minimum. If the sign diagram changes from positive to negative, you know at this point that it's going to be a maximum, okay? So that's how you determine if a point is a local maximum or a local minimum. All right, so to summarize this, so first of all, some terminology we need to know. So a stationary point, right, that's any point where the derivative is equal to 0, all right? So any point where the derivative is equal to 0, we call that point a stationary point. Now, a stationary point can be a local maximum, it can be a local minimum, right? Or it could be what we call a stationary inflection, okay? So just like we talked about earlier, a local maximum, if we look at the sign diagram for the first derivative, so it's a local maximum if the sign diagram goes from positive to negative, because then it's this value here, right, this point is the highest point, right? If the sign diagram goes from negative to positive, so if it goes from negative to positive, then this point is the lowest point, so then it's a local minimum. Okay, so positive to negative on the sign diagram, it's a local maximum. Negative to positive on the sign diagram, it's a local minimum, right? Now, what if the sign does not change, right? So if on the first derivative sign diagram, if the sign does not change, basically what's happening is if it stays positive to positive or negative to negative, we have to visualize the graph, so what's really happening. So instead of going from positive up and then negative, So basically what's happening is it's going up, right? So for example here, positive and then positive. So it's going up. And then at this point here, right, it has the derivative is 0, so it has a horizontal tangent here. And then it just starts continuing up. So it never changes direction and turns back down, right? Or the sine diagram can go from negative to negative, right? So negative to negative, it's going down here, and then it has a horizontal tangent line here where the slope is 0, right? And then it continues going down, so it never turns around and goes up, right? So when your sine diagram, right, on the first derivative, when the sign does not change, we call these points stationary inflection points, okay? So when the sign changes, it's either going to be a maximum or minimum. So if it changes from positive to negative, it's a maximum. If it changes from negative to positive, it's a local minimum. If the signs do not change, then we call these points stationary inflection points. Okay? Okay, so let's take a look at this example here. So they want us to find and classify all stationary points, right, for this function. So first of all, remember, stationary points are any points where the derivative, right, where the derivative is equal to 0, okay? And stationary points, remember, they could be a local maximum, a local minimum, or they might be a stationary inflection point, okay? So now the first thing we need to do is we need to find the derivative of this, okay? So this is going to be an easy derivative. So this would be 3x squared, right, minus 6x minus 9. So then we set the derivative equal to 0. So then we have 0 is equal to, I can factor out a 3 here, 3 parentheses x squared minus 2x minus 3, right? So if I continue factoring this, this is going to be x. So we've got x minus 3 plus 1, right? So that gives us a negative 2 in the middle, right? So the values that will make these factors a 0, that would be x equals 3 or x is equal to negative 1, okay? So once you have these values here, right, so you find the derivative, you set it equal to 0, and you find these x values. The next thing you want to do is make your sine diagram. So we make a sine diagram of the first derivative, all right? So this is a sine diagram for the first derivative. So our values are negative 1 and 3. So these are the values where the derivative will equal 0, okay? And then we need to test some points. So to the left of negative 1, let's say I test negative 2. If I plug negative 2 here and here, all I care about is, will my result be positive or negative, right? So if this is negative 2 minus 3, I would end up with a negative. If this is negative 2 plus 1, I would get a negative. So then we know that we have a positive here. Negative times negative is positive. Now between negative 1 and 3, I can test a 0. If I plug in 0 here, that would give me a negative. If I plug 0 here, I'll get a positive. So then I end up with a negative. So to the right of 3 is 4. If I plug in 4 here and here, I would end up with 4 minus 3, that's positive, and 4 plus 1, that's also positive, so I get a positive, okay? Now one thing, make sure you're careful. These signs here, they don't always alternate, so some students think, oh, if this is positive, this always has to be negative. That's not true. You have to really make sure you test some points, some x values, to really find out if it is positive or negative, okay? So now that we have our sine diagram, we can determine if these are local maximums or minimums. So just think, if the graph is going from positive to negative, so just think positive to negative, so that means this is the highest point, so we know when x is equal to negative 1, there's a maximum, right? And then over here is going from negative to positive, so negative to positive, we know when x is 3, all right, we know that there's a minimum there. Now, you need to give your answers in coordinate form, because anytime IB asks for points, they want x and y coordinates. So you have to give both coordinates. So when x is negative 1, right? So when x is negative 1, when x is equal to negative 1, we need to find the y value. To find the y value, you just plug it into your original function. So we need to find f of -1 is equal to, so we're going to plug it into our function here. So -1 cubed, that'll be -1. -1 squared is 1 times -3 is -3. And then this will give us a +9 and then +5. So if we work all this out, this is -4. So we end up with 10, right? So our coordinate when x is -1, the y is 10. And at this point, we know that it's going to be a local maximum, right? It's going to be a local maximum. And then we just do the same thing for the other x value. So when we have x is equal to 3, when x is equal to 3, we want to find out, well, what's f of 3? Plug it into the original function. So 3 cubed is 27. 3 squared is 9 times -3 is -27. And then 3 times -9 is -27. And then +5. So it looks like we end up with -22. So we know that when x is 3, y is -22. And at this point, we have a local, right, minimum. Right? So anytime you're asked to find if a point is a local maximum or local minimum, just remember that, oh, this deals with the first derivative. I need to set it equal to 0 and then make my sign diagram. All right? And then use the sign diagram to determine